Welcome to today's online industry meeting focused on the future of optics in virtual reality, where we will explore the evolving needs of next generation VR systems, especially focusing on improvements in resolution, image quality, and wearability. These advancements are critical as the VR industry looks to support both consumer and professional use cases in increasingly diverse fields. We are thrilled to have Douglas Langman, Meta's Senior Director of Display Systems Research, to provide insights on Meta's development in VR technology. Meta's recent Quest 3 headset represents an exciting leap forward in affordable consumer VR, offering visual clarity and a comfortable user experience. In addition, alongside this consumer focused, we will hear from Stan LaRoche, CEO of LynxR, whose headset caters to professional applications, emphasizing industrial use cases where precision and reliability are key. In addition to our hardware experts, we will be joined by Johan Cruz, Competence Development Manager from Volvo Trucks, who will provide an end-user perspective and their preferred future. During the pandemic, Volvo Trucks faced a challenge in bringing a new electric truck to the global market. How could they train more than 20,000 service technicians around the world when neither trainers nor trainees could travel? Volvo took advantage of virtual reality, showing us all how to rethink new ways of training and learning. So what will Volvo develop next, and what photonics technologies do they need? As usual, the format of our online industry meeting links end-user needs with photonics companies. This time, it includes companies in adaptive optics such as Adoptics, Optofidelity, and Phasix, companies in wafer-level optics like Alphamation, and contract manufacturers like the giant Jabil. In addition, innovative companies such as Nexus Photonics and Insight are here with us. So let's get started. Let me give the floor to Optica's Director of Optical Systems, Dr. Olga Ras. Olga, the floor and the attention of everyone is yours.
Guten Tag, guten Morgen, bonjour, buongiorno, and dzień dobry to everyone in the room. Welcome to our VR, our special online industry meeting on VR. And you know, while all the world is concentrating and waiting for the tidal arrival and adoption of the augmented reality, virtual reality has already secured a very good niche and keeps growing. So today we're going to dive in more into the really advancements of the VR. And today we're joined by the cohort of excellent speakers, both on the end users and developer side, as well as the solution providers. So join me in welcoming our speakers from Meta, from Volvo Trucks, from LynxR, from Phasix, Alphamation, Insight, Jabil, and many others. And beyond this, we're also together in the room with more of the 100 of our corporate members, which are all aligning around different levels of the supply chain. Together, we are forming a complete supply chain for providing everything for the development of the VR and IR solutions, starting from the photonics photonic integrated circuits, micro optics, waveguides, semiconductors, and then going into the really materials and everything that you need to enable the entire system to function. And today we're going to discuss and dive deeper into the latest advances in the VR field. And before I give the floor to the first presenter of today, Douglas Langman from Meta, I would like to remind you that we're actually live in YouTube, so YouTubers also welcome. And I would like to call out to the floor one of our actually unusual speakers, the Johan Kruse from Volvo Trucks. Johan, it's the first time that you're here, and you know, as the end user, not the person that is developing the sets, but really is now in the same room with the tech guys. Tell us a little bit more. What's your expectations from this meeting?
Wow, I'm so happy to be invited to this meeting, and I'm really looking forward to hear about the future, what's coming, and also to get a glimpse of what's coming next and so on. Because, yeah, I will talk more later on about our journey.
Exactly.
So,
I
yeah.
believe you have a wish list, and we're very much looking forward to hear, what is on your wish list for the future of the VR. Thank you so much for joining us, and let's proceed smoothly. I would like to introduce the first speaker of the day. It's my greatest pleasure, and actually, I was trying to get Doug to speak several times on the VR or on the display technologies, and he was always very humble, saying like, "Next time, next time." I'm happy that I have you today, Doug. The floor and the attention of everyone is yours. Please welcome Doug Landman from Meta.
Thank you so much for the introduction. So hopefully you can see my slides.
Yes, crystal clear.
Great. Yeah, so as Olga was saying, I've been hoping to join one of these events for a little while. And the first time I received the invitation, it was not quite a year ago, I believe. And the question hasn't changed. Olga asked me, from my vantage point, working in the industry for over a decade now, what do I think's needed for more useful, really VR displays is the point of this, but really like XR in general. Oh, recording is in progress. So that's really what my answer is today, and obviously the first caveat here is these are all personal opinions. Yes, I work inside a company, but this is really informed by just pushing this technology for over a decade with my friends across academia, within my own team, at partners. And I think any of you who've seen the work from my team, obviously a lot of it really is VR and MR focused up to this point. And you sort of know the things I think were important. Like when I started in this field about 10 years ago, VR headsets like the Rift, which were not even quite on the market yet, didn't have anything close to retinal resolution. They were grainy, they were bulky, they had distortion issues. They certainly didn't solve accommodation. And so I saw sort of this as really the menu of things, the priorities we had to chase. And, myself and my collaborators, we eventually gave a name to this, of passing the visual Turing test, of trying to bring VR headsets up to parity with every other display we have in the world. But then, of course, try to push it beyond, to try to make something that as close to a portal into a virtual world that is realistic as possible. And so at this point, coming into the meeting in this year, we've been at it for 10 years. And so if you're curious to see what we did, there's a blog post we put up a little while ago, and it summarizes all these directions we tried to push, particularly in VR and MR. And probably what I'm most proud of is rather than just talking about these ideas, we tried as best we could to push forward. And so, in our lab in Redmond, Washington, we have a couple dozen headsets, and each of these tries to push one axis, make a fully high resolution, beyond retinal resolution headset if you can, make something that solves vergence accommodation, make something that's 10,000 nit high dynamic range. But this was never the ultimate goal. These are just time machines that give us a glimpse on each axis of the future. And the real goal was to bring it all together. But you can see the challenge, right? If you look at any of these prototypes, just grab one off the wall. Here's our holocake prototype. It's a holographic pancake lens, right? And so this is an evolution of the industry standard refractive pancake lens. It allows us to bring the form factor in, expand the color gamut, and essentially make a much smaller device. But then if you pull another headset off the wall, something like our varifocal headsets, right? They use mechanical actuation to move screens or lenses to change the focus. And so just these two devices, can you cram them together? Can you make a holographic pancake lens that supports accommodation? And if you do that, then you'll want to solve pass-through. And so then you get yet more technologies, right? So if you want to have a perfect pass-through experience with no distortions whatsoever, perhaps you can use something like a light-filled camera here in our Flammer prototype. But now if you have perfect pass-through, an ultra lightweight headset that supports accommodation, then in order to bridge that gap with AR, I believe you do want to see your face. And so we first introduced this concept of reverse pass-through a few years ago where we use light-filled displays on the outside. But you can see the challenge. These are all glimpses of a potential future, but they don't necessarily come together, right? The light-filled displays block the light-filled cameras. The holocake lens has such a compact design, can you really put mechanical elements into it? And so I'd say at this point, to talk about what could be more useful in VR and MR, we came up with one proposed architecture that does our best to thread the needles. And so this is something hopefully you've seen out there before. It's called Mirror Lake. It's just an architectural concept. It doesn't exist in its complete form. Obviously, it exists in pieces. But this shows a glimpse of what VR and MR could become, right? Imagine if we could take this step change and have much lighter headsets, much more comfortable headsets that tackle all these axes and bring us closer to passing the Turing test. So for the rest of this talk, I'll assume that this class of device will come into being. Certainly as a researcher, I believe it's possible. And of course, we're already working on things that go beyond this Mirror Lake concept. And so that's really now, I'm going to transition to that personal opinion side and try to answer Olga's original question. And actually, the challenge I got from Olga made me think about this over the last year. So these are some thoughts that have been brewing in me that really came from the first invitation to this talk. And so I figured the only way to answer her question honestly is not to pretend I can intuit the will of the world, right? I'm not a product person. I'm not going to do some focus group. So I realized the only one I truly know in this world is myself. So I'm going to answer a modified version of your question. What would make VR and MR more useful to me, just Doug? If the whole world was me, this is what I think they need. And by trying to answer this question, I'll try to project, are we actually working on the right technologies in VR and MR? And so from first principles, all of us in the panel generally fall into two big buckets, VR or MR, you could call it, some sort of blocked light device, and AR, some optical see-through device. And we know there's all these wonderful products we want to make, but sadly, physics and reality constrain us to something that is tech ready. And so if you look at the mass market wearable devices, display devices, there's really only two buckets that I see right now. There's immersive entertainment, things like Quest, and there are smart glasses, things like Ray-Ban Metas. Out of all the products we want to make, these are the two that are really tech ready, that we can push forward. But of course, there's all these other wonderful products we imagine. And it's all of our jobs in this industry to try to expand the tech readiness to make these products possible. But the question is, which vectors do we need to push on? And so that's where I'm going to survey my day. So here it is. You can still shot this, but this is my average Tuesday. So this is not an average Tuesday today, but this is what it looks like for any given week for me. From getting up, commuting to work, having too many meetings, so on and so forth. And looking at my average day, doing the market research on myself, I realized that I need a VR and MR headset that can run for 13 hours a day, right? I'm staring at a screen 13 hours every Tuesday. But what's interesting is, what screens am I staring at? A third of my time, I'm looking at a phone between meetings. That's not a surprise to me. 70% of the time, I'm looking at a laptop. That's good. I'm a tech worker. I should be doing a lot of work. What's a real surprise to me is 40% of my day, I'm looking at some television screen while I'm looking at these other things. And it's not because I spend like my whole day watching Netflix. It's because I'm at Meta and I'm sitting in conference rooms looking at big screen TVs for video conferencing. That was a surprise, so I guess market research can work. Now, I'll be honest, as a consumer, not during my day job, but as a consumer, about 1% of my Tuesday computing needs are met by VR. Occasionally, I'll play some new game. None's met by AR. Until recently, I got a pair of Ray-Ban Metas recently. I got some X-Reels recently. I haven't been using AR, so 0%. But if I imagine, it's not that these things aren't useful, it's that we're still building them. If I imagine where I think these things can get, if I just think about the scenarios in my life I can use these things, about 3/4 of my day, I could use something like Mirror Lake or the evolutions beyond it, some amazing VR MR headset to do work. But 100% of my time, I can use an AR device. And so this is already pointing to what I need as a consumer, is I think I do need the optical see-through, but in perhaps something more like a VR headset, field of view, and performance. This was also part of my survey. I realized I got a lot of good data. Half of my day, I'm by myself doing email or whatever, but only about 10%, 12% Am I in public? And so, whenever we think about the AR future, we worry so much about making it look elegant and fashionable and socially acceptable. But as a middle-aged man working in tech, I'm not going to a ton of Starbucks. I'm biking to work occasionally, and I don't really mind if I look nerdy doing that. So for me, the form factor is actually not as critical as the performance to make my day more productive, to be productive with groups and family. So it's that 85% on group that matters. And so again, I'm really trying to dive in and be honest to myself. As a researcher, am I making the technologies I think I personally need to have something that goes beyond the devices I have? So here's what I got. I think the industry is starting to push the right way. It's not just about VR gaming. We do need to replace laptops and televisions, in my opinion. We need really immersive, on-the-go 2D displays. So that drives a lot of the tech requirements we've been working on. I think Mirror Lake is aligned with these. But the power and the weight and the comfort is much more vital than I think we take, on the vectors we're on in industry. If I'm going to wear this thing throughout 13-hour day and occasionally charge it so it's only 5 to 9 hours of use, you got to make this thing really close to glasses, right? You got to make it very light. And perhaps the only way to do that is to tether it, which is also sort of a different vector than what we're seeing. And then the form factor one I already harped on, but I don't think we need to make it so elegant. Perhaps this is our get out of jail vector, right? Obviously, if we tried to use waveguides and some real AR technology, you couldn't cram that into a wide field of view device, right? That solves accommodation and do all these other things. And so fortunately for me, you don't have to. And what would I use it for? 2D screens, great telepresence like I'm using right now, 3D visualization. I actually don't think the applications are so hard to imagine as we pretend. And so to wrap this up, make sure I don't take too much of my time, this is how I see the industry from Doug's vantage point, is that what we're really doing is we are trying to build to a laptop and TV replacement. You see that in a lot of the marketing ads for all the products nowadays. But the way I think my team's been building, Mirror Lake is trying to build up from immersive gaming to try to evolve a VR headset into something you can use productively through your day. And so perhaps my answer, this panel is mostly AR folks, is I relent. The next 10 years, I think we should start at the humble smart glass and try to build up, perhaps through less elegant form factors, to something that is truly optical see-through, comfortable to use. And obviously, I'm not the only one. I'm a latecomer to accepting that perhaps the best VR is optical see-through. And so we see all these devices in the industry. These are the things I think we need to work on, right? Coworker and family acceptable rather than whole world acceptable. Lightweight, open periphery, rapid on-off, super great power and comfort, which means a lot of the work that I've been pushing the last few years, getting pass-through to be great, I think it matters. MR headsets are going to be incredible, but as a researcher, I need to work on the next thing. And so perhaps distortion and latency can be solved perfectly by having great pass-through through optical pass-through. But now we come back to occlusion. That's the key weakness of AR. We should be doing more on that as an industry. So that's what I need more from VR MR. I need more AR in it. And so I'm trying to live my values. So the last 10 years, I really tried to deliver with my team a vision of what MR can become. And I think we'll see things like this. We're already seeing pieces of this in the industry. But with my students at the University of Washington, I'm taking these little old combiner optics and trying to play around with them, watch movies in them, walk around, see if my family finds them less objectionable than a VR headset in the living room. Obviously, this is not the end point, but I think it's an interesting place to look. That is pass-through, digital pass-through, VR and MR, the ultimate destination for people like Doug? Probably not. Probably we need to start finding some new architectures between waveguides and pancakes. That's what I got.
Thank you, Doug. Doug, do you also have the Orion, the new glass?
Yes, certainly we've had that for many years. I'm very excited about it. And something like Orion obviously jumps us forward, right? That if you look at the things I want, well, there it is, right? It's more fashionable than what I described, right? I feel like, these little combiner things, are not a great start, but I'd entertain them as a user. So yeah, Orion jumps all the way to near glass's form factor. It's lightweight. It's open periphery. You can take it on and off quickly. Has, a pretty close to VR field of view. And if you could tether that thing to a battery, you could run it as long as you like. Now, obviously, my company has spoken at the cost of that, and that's not a consumer product. And so I think I'm coming at this as a researcher who's made progress with the team in VR and MR. And I think VR and MR is much more tractable to progress because the form factor is so much larger than glasses. And so I think trying to see if you can take that form factor and evolve it into optical see-through, but keep that cost way down, right? I mean, you look at the Quest 3S, very affordable. AR glasses, not so much. And so I guess that these things, of course, in the far future will all merge into one thing. But in the near future, I think building up from VR is different than trying to scale AR glasses to do all the things I need throughout my day. So I think there's room for both, but I haven't yet seen optical see-through sort of in an MR-like device, and that's what my survey was sort of pointing towards.
I see. Thank you so much. Do we have any probably questions from the audience or maybe from some of our presenters? Then I'm curious because you've mentioned that so you will still need basically for the IR VR experience, MR experience, you would need some type of the projections, right? And in the classical VR headset, that is usually a display in front of your face, and the displays are very well developed. You have now pretty nice OLED displays, but for the MR part, it becomes more tricky, right? And we know with some massive exits earlier this year, this entire strategy of the mini displays implemented into the light engines became difficult. What do you think, like from the perspective, what would be the light engines behind the mixed reality sets?
Yeah, so I use this venue to speculate. Usually I don't like speculating in my talk, right? It's easy to say, hey, could there be something between smart glasses and VR? It's easy to say that. Obviously, the industry hasn't found something like that. Other than this little product, right? These little display glasses, like your X-Reals and those sort of companies. And so being in an optics community, we all know it's étendu, right? If you start with a panel, it's quite easy to have a large eye box and a large VR-like field of view. Start with a little projector, and now you're going down the path of pupil replication to expand the étendu. All the image quality is lost. Form factor is great, but field of view is small. And so I guess my intuition, if we're just sort of thinking of this as gradient descent, the closest device to what I'm talking about probably are these little bird baths, but their field of view is tiny, right? It's enough to watch a TV show, and it's wonderful to do that, but it's not enough to maybe like sit in a virtual environment, see like virtual colleagues, be productive, go about my day. But my hunch would be you probably, if you can tolerate a bigger form factor, start with something that's a panel, have a lot of étendu, try to carry that with the optics, which means maybe some bulkier optics. That's exactly what these freeform combiners do. They just do it poorly. And so, yeah, a panel-based device seems like a sensible way to start, but it means already you will not look like glasses, which is why I said the goal I found is, can you make something that is still elegant and interesting and as approachable as these reverse pass-through MR headsets? Then yeah, probably a panel, because otherwise you're just making the same waveguide we're already making in AR, and we sort of know that those are proving to not sort of reach those VR-like fields of view at affordable costs.
We have a question actually from the university. Let's Khan Akshit from the university.
Oh, I know Khan very well. Hi, Khan.
Yes, Khan. So please unmute yourself and go for question.
Thank you, Doug. Excellent presentation. My question
Oh
is
yeah, I
about
also know Khan. Now
Oh,
I
yeah,
see the
we all
face.
know
Now I
Khan.
know that. There we all know Khan.
so my question is about these X-Real glasses or glasses like X-Real glasses.
Yeah.
They all use bird bath optics, and it's often the case that we have these secondary reflections in these type of glasses. They are highly functional, useful, but it kind of kills the experience. Do you see any ways to maybe fix that in the future? Like, for
So,
example, this off-axis beam combiner, can it be a good alternative to these things?
so yeah, it's interesting. It's obviously I'm speaking to the Optica community here, right? We're all trained and we all care deeply about artifacts. But then the spirit of what Olga asked me, I tried to imagine myself as a consumer. And the truth is, right, like I say X-Ray only because that's the brand I happen to purchase. ever since Olga asked me to give a talk like this, I started getting these devices to try them. And I guess I have to say, as a consumer, the birdbath optics do what they need to do, right? I can't walk around. I'm not walking around with them, having conversations, making direct eye contact. But am I like sitting on a bench while my kid gets a piano lesson and watching Netflix? Yes, right? So actually, to me, you use one of these bird baths and you're like, wow, someone who works on waveguides should not be allowed to see this because the image quality is so beautiful. They'll just give up. And so I think we have to be realistic that these devices are not direct view displays. They're going to have little rainbows. They're going to have ghosts. They exist in all the products, even pancake lenses, but don't let the be perfect be the enemy of the good, as they say, right? That we can still have a lot of fun and we can be artistic, right? Don't put a big white logo in the middle of nothing in VR and AR devices, right? Be smart in your content design. So I'd say, yeah, these are all realistic problems, but also if you look past them, are you making something of utility to the user that's better or different than a laptop and a phone? Yeah, right? Sure you are, right? So I think a few ghosts are not the end of the world, and perhaps we over-index on that a little bit, too much in our community.
Thank you.
Doug, because I'm also curious about, you have basically all these front beam combiner, right? Which usually probably should include waveguides, which are encapsulated in some type of the optics, which actually also have to be adjusted to individual user. And I think we have one of our members, which is Ad Optics, that are working on creating very complicated customized lenses that are suitable for also not blurring, but incorporating the waveguides into them. And so I would like to call to the floor Josh Littlefeld from Ad Optics to tell us about a little bit more because they are providers on the side of the optical experience and optical visual appearance. So what do they bring to the table, Josh?
Gotcha. Thanks, everybody. Douglas, I agree with the great majority of everything you said there about, especially the being a middle-aged man. So completely agree. I've recently joined Ad Optics as the chief commercial officer. But I spent the last 10 plus years as a waveguide and device person for AR. So an awful lot of what you've talked about is the goal of AR, and VR started everything, right? And your points about having the device usable is the most important thing, right? We were asked to keep it very short on these little one sheet presentations. So just as a quick background on who Ad Optics is, Ad Optics is primarily built from the beginning for AR, right? And it's a fully integrated prescription lens, and I'll go into the official explanation in a second. But when you see the document here, we have a question of, will what we do in AR work in VR? And the answer is yes. At the end of the day, consumers, end users, and oftentimes in the AR and VR space, whether you're an OEM or an ODM, they want everything to be just perfect, when in reality, the end user wants something that works, right? So if you think of the bird bath side, it just works, right? But it's not the greatest, look and feel and things like that, right? But it's a good product, right? And it's inexpensive. And I do think that the prices, this is the Josh personal opinion, the costs of waveguides and displays in the future will go down. It's just a scale thing, right? So as people start launching products, they're doing millions of devices, that price is going to plummet. But what Ad Optics does, again, we primarily started in the AR side, but what we do works in VR as well. Ad Optics integrates prescription lenses to existing AR and VR devices, whether they're glasses or if it's a headset. So this approach can let both of those become prescription ready without actually having to make a change in the device itself. So if you're an OEM or an ODM, you don't need to change the form factor, because the prescription lens will integrate directly with that optical lens to allow you to have a normal size lens, right? So you don't have these big, huge, thick prescription lens with a waveguide or with a display. most VR devices, as we all know, have a clip-in prescription lens. And that's not a good solution for the end user or, frankly, for the OEMs or the ODMs. It's very expensive. It takes a long time to get them. It's just not a very good offering. With AdOptics, again, AdOptics integrates directly with the lens, whether it be a VR lens or if it's a waveguide for AR. It's a direct integration. And what this allows is for a minimization of reflections and distortions, while also allowing for technology to be directly embedded into the lens rather than the frame. As an example, eye tracking. So you don't need to put the eye tracking up around the frame and having issues. Instead, it's directly embedded into the lens itself. In addition to the integration of prescription lenses into lenses, AdOptics has a key enabling manufacturing technology that allows for a solution where if an organization needs a high degree of individual prescription lens customization at a really large scale, AdOptics makes it possible. And that's this AdOptics mold technology that you see here. So it's a big part of our IP. To sum it all up, what it allows you to do, instead of an end user waiting months for a prescription lens clip-on that then just clipped on to a VR device, instead, end users can receive their complete AR or VR device with a fully integrated, individualized prescription lens in less than a week. In actuality, we can do it in 3 days. So it's very fast, it's very scalable. And again, it removes the need for a clip-on, right? Or a big, huge, thick lens. Instead, it looks and feels like a normal prescription lens glasses if it's AR, or it's a fully integrated lens that's prescription-based for a VR device. I could go on for an hour or 2 hours, but 1 to 2 minutes, that's just a brief overview of who AdOptics is and what it brings.
Thank you, Josh. I'm curious about to hear about more about your flexibility with the materials, which materials you can use, because we know that the latest design of the IR glasses from Meta, right, that has a silicon carbide lens, which is very exotic material. What do you have on the plate to cater to increase the field of view and
yeah. Well, so what prescription? So with AdOptics does not change the field of view, right? So that's the lens with the device, right? So what AdOptics does is, regardless of what the material is, there's an integration directly with that lens to allow your individualized prescription to be available, if that makes sense. So it's a little bit different.
But do you have a selection of materials, or do you only work with one, or maybe very limited, or let's say two, three?
So think of it more as like a high refractive index material with strong diopters, right? So we can integrate with anything like that. So the materials are the same for regular eyewear. So, most people, most prescription, you can still get prescription lens that's glass, but 1% of the world uses that and it costs you thousands of dollars. So most prescription lenses are plastic. So we bring that prescription lens that's fully integrated with whatever material that's there. So it's going to look through, it's a high, refractive index. So think of it as PPG. So if you use PPG materials, then you can integrate it directly with a lens. So it won't affect whether you're using a waveguide or a VR lens. It won't affect the display at all.
Thank you. We actually have a comment from another developer of the VR solutions, VividQ. Mark Brennan, please unmute yourself and ask your questions. It's actually a question for both to Josh and to Doug.
Hi, thanks. Both really interesting talks. Thanks for both those. My first question was sort of for Doug, but I guess it could be to the room as well. Do you reckon that there is a varifocal solution for AR headsets? Because I know we know there's some Meta prototypes using varifocal for VR, but I wonder if you've done any testing for the same thing in AR, or if you found that the aberrations it induces kind of make it jarring or anything like that.
Yeah, so I guess, again, I told you I'm sort of unsettled by giving talks that are speculative like mine, right? I'm just sort of like, hey, there's something over there, we should go there. And so, yeah, I guess in a sense, it's like my team had fun. I had fun for 10 years pushing MR. I guess I'm sort of saying, let's take a look over there. I mean, there's obvious stuff, right? Like if you do have a panel-based design, I don't think we really want panels in what I'm describing. But sure, you could move that panel and it's going to have some aberrations. Is it going to make it too bulky? I mean, I think that's why I'm excited about it is it's sort of this new space. Now, if we go straight to waveguides, right, then the options for accommodation, as we all know, are not great. Yes, my team's played in that space as well. If you do a holographic waveguide, you invert all those rays and system of equations, yeah, you could accommodate through it, but we know that's a ways into the future. So I guess I'll say, like, isn't it great that I don't have an answer for you because it means there's something fun for us to do.
Hey, Mark.
Yeah, cool.
Josh,
Mark,
do
it's
you
good.
have a comment?
Yeah, Mark, it's good to see you again. With my previous world over at Displex, and then before that Magic Leap, and then Daiquiri, yes. So
It's a small
for
world.
yeah, and I know you guys very well, but as ad optics answer to that, I agree with everything Douglas just said. So there's lots of options. Technology wise, ad optics can do that, yes. It's just a very complex lens design, right? And so the more complex it is, it means the longer it takes, which means, frankly, the more expensive it is. And then, anyone can design something in a lab, but to make it mass producible, it's different. Mass producible at scale, and then with quick turn times, and then affordable. So there's lots of options that you can make anything. But again, it's got to be something that the end user will end up paying for, right? And that they'll like. You can use some really fancy materials and do some amazing things, but can you scale that to do millions and millions and millions of them? Yeah, maybe, right? But it's going to cost. So, but again, we'd be happy to do it if you have a project. Anyway, that's a different story.
And then, the more
Absolutely.
complicated it is, the more difficult it's also to measure it. And here I would like to introduce to the floor our next speaker, Valentin Genwer from Phasics, that are basically using the wavefront sensors to measure the most complicated surfaces with the large deviations from the flats. Valentin, the floor and the attention of everyone is yours. Please tell us what you do and what's your solution for the tricky world of the VR push and pull optics.
Hi everyone. Thank you, Olga, for the nice introduction, and thank you very much for all the nice talks and introduction to technology. So I'm Valentin Genua of Basics, so field application manager here, and really what I wanted to say is, so we work on the metrology side. So after everyone is having ideas and then developing technologies to apply those ideas, so we are on the metrology side to make sure that all the functions that people want to make, that they are actually making them. So really making sure that those optics are behaving well. And I think that's also something that Douglas mentioned as well, is that the user experience, the user perception side is also important. So you have a lot of optical technology that are pushing things, but one thing is really the user perception as well. And so at Phasics, we are working at the frontier between measuring, so I would say components and measuring systems, so doing the metrology, but also trying to link, I would say, classical metrics and performances of this kind of metrology system to the user perception side and user experience. So Phasics, in few words, as an introduction, so our core expertise, yes, is doing high resolution wavefront measurements. So we do that in a lot of wavelengths, from the deep UV to the long wave infrared range, but visible is mostly what is used in VR. And we do make wavefront sensors, so cameras that are able to measure and sense spatial phase distortions as just standalone sensors that can be integrated on setup or production lines. We also do like metrology kits that can be integrated to support upstream R&D in development of this technology that can adapt to various dimensions of optics to test and a lot of wavelengths up to the machines that will be on the production floor. But really, if I wanted to highlight maybe two main applications that we are working on in this type of industry, so VR and also AR as well, and MR, is first the metrology of components, either static, like lenses, metasurfaces, mirrors, combiners, and also dynamics, that the one we have seen with manufacturer integrating varifocal systems to try to solve the divergence accommodation conflicts, and trying to catch any wavefront distortions and any thing that could disturb the user experience when these systems are behaving. So in terms of metrics, we provide wavefront AR, of course, modulation transfer function, but all the optical aberrations. And to jump on what Josh mentioned as well is combining VR and AR systems with prescription devices. There is a huge need as well to check and just verify diopters of this kind of system, just for example, as a calibration in production, but also just as a verification. And we do everything of this at a high tempo and a very high spatial resolution range. And then so in addition to this metrology of, I would say, components, then we also work on the assembly side when people try to assemble, for example, a display with a lens system, and assessing, for example, one metric that is very important is where the image is sent. So virtual image distance estimation and measurements. So yeah, in few words, that's what we do at Phasics. So supporting upstream R&Ds, crazy ideas, and trying to also solve problems in production for the VR industry and AR.
Thank you, Valentin. So, Josh, challenge Valentin, some of your most unusual lenses that you have developed. What was it, and can Phasics measure it? What's your challenge?
Well, so that would have to be in my previous companies.
Go for it.
Well, I have to be very careful because it's all custom designs for OEMs and ODMs. So if I were even to express the materials or whatever, then I would disclose what these people are doing. So unfortunately, I cannot ask those questions. I apologize.
Okay, thank you, sir. Thank you anyways. But then, Doug, I have also a question, because if you're saying that let's say that you prefer that we move, and you see that we move rather into the MR, then in comparison to the VR, which is more or less a display, then we also are very sensitive to the eye tracking. And what's your view on that side of the things?
Yeah, just sort of to make sure I understand your question, sort of how we would achieve eye tracking.
Yes.
AR. An AR
I
like
mean,
that.
there are already quite a few systems, right? Because it is possible. But what are the horizons? What do you think?
Yeah, so this, like, coming back to that mirror lake concept I mentioned, you know, we did actually use I've used Phasics to measure varifocal systems we built over the years, so that bullet's very near and dear to my heart. Obviously for varifocal, you know, in a VR context, and certainly like the sort of AR stuff with bird baths and combiners that have a lot of pupil swim, you need very good eye tracking, not just gaze angle to get divergence, but the 3D pupil position to correct distortions. And so at least the solution as a researcher, you know, we're always looking for the best eye tracking we can get, right? If you have one camera, it's difficult to get the pupil because you can't triangulate. Modern systems use a couple cameras. What if we had a whole bunch of cameras, and how would you do that? And so once again, since we love holography in my team, I don't know if this would be practical in the end, but the sort of system we like to use, it's a holographic combiner. And so in the IR wavelength, you pattern basically a bunch of little mirrors, and then you have a single camera, but put your money into one camera, and you know, and you can also put a source there, and the hologram can generate your glints. And so I guess for AR, I'd say, since we know the combiner plane has to be thin and see-through, then I can make that out of a single analog hologram, and I can image through that. And so that's what we've sort of proposed and demonstrated in our research. You know, is that the ultimate solution? You know, I don't focus exclusively on eye tracking, but I thought that was a decent solution to give me a bunch of views, and that was intentionally designed. You know, most of the industry isn't going for this really accurate 3D pupil tracking because we're not doing varifocal as an industry yet. We're not doing dynamic pupil swim correction in the majority of products. But I think if that's the goal, a lot of views is a good way to go. And you don't want those views to be at the periphery of a big wide field of view system. So hologram in the center is my preferred solution that I know of.
Let's see, because we have member and also an attendee who is specifically concentrating only on the eye tracking. It's Piotr Krukowski from Insight. Piotr, tell us what you do and about a little bit more about your solutions for the eye tracking.
Hello, everyone. This is Piotr Krukowski from Insight. And what we do is an eye tracking technology that is primarily built for augmented reality and smart glasses because of a few superpowers of our technique, which is the ultra low power consumption that is not exceeding 3 milliwatts and form factor that is matching with expectations of modern looking eyewear, smart eyewear. However, we don't stop here. We also are planning to launch an eye tracking add-on for Meta Quest products that will unlock new gaze-driven capabilities for existing VR solutions, like social VR eye contact, like dynamic foveation for PC VR content, foveated encoding, and research. We received significant attention from B2B and B2C, and actually we are more than happy to get even more, as we recently turned into commercial phase and secured first commercial products with AR and smart glasses OEMs. So I'm happy to share a few words about Insight Lumi and our technology. Thank you.
Thank you, Piotr. Then I will probably ask another one of our speakers, Stan Laroche from Links. Like Stan, what will be your challenge for Piotr? No, because you're also, I'm very sure, implementing the eye tracking system into your devices. What would be the performance that you would like to have?
Yeah, I can't confirm or deny that we are also working with eye tracking. We are absolutely interested in Insight. We're following what they're doing. I think the main from my perspective as a headset manufacturer, I also have the economics in mind, and usually eye tracking as a feature in a headset has $50 to $100 in BOM cost and in calibration at the factory and all of that. So there are not a lot of headsets today or even glasses that have eye tracking in their product, because at the end of the day, it adds up a lot in the cost of the product. So I think the biggest challenge for eye tracking to be more widely adopted is reducing the cost. And I know Insight is in a great position because they have solution where they can completely remove the camera, which is super interesting. So yeah, I think that would be the greatest challenge. It's not on the algorithm, it's not on the power consumption anymore. I think these things are done for. It's mainly now on the price and tooling and getting it into the product. I think that's for the next generation headsets what we should take a deep look at.
Yeah, that's fully
Piotr?
correct. Our mission is actually to make an eye tracking that will be affordable. So the components that we use are off-the-shelf components, mainly photodiodes, infrared emitters, and some set of electronics that is basically cost-effective, widely available, and can reach a very little bill of materials. So this is why we also believe our technology is well suited for widely adopted XR devices, as each dollar in the manufacturing weighs much more on the shelf, right?
Well, then I hope to see more of them, more of the eye track systems introduced actually to the headsets. But Stan, now it's after being a challenger, it's now your time to present what you actually do. So the
Yeah, hi
floor
everyone.
and attention of everyone is yours.
Yeah, I hope you can see my screen and hear me okay. I'm Stan
Perfectly.
Larocque. I'm the CEO and founder of Lynx Mixed Reality. We are based in Paris and we make mixed reality products. I just want to take 30 seconds of my time to say that to say thank you to Doug for his talk and that I really admire his work and what his different teams have been doing. It's really great to have someone in the industry like Meta that can pour so much money in that, because smaller company like Lynx can absolutely benefit from the supply chain and what ends up in the different products. So because I'm also the CEO, I have to deliver things, I have to make money, but mostly to survive, because AR and VR is still a very small industry, and I think people have seen different waves. You can say wave of technology or waves of layoff or wave of money poured in, I don't know, or fundraising. But definitely there are ways and patterns that we see now in this industry. But what's clear is that a lot of people are passionate about this, and whether you like it or not, it's happening. Where you talk with these big companies, there's just so much money and so many smart people that it's also part of the future just because of that, and those products are going to be pushed to the general public. They are very hard realities when like Doug, you start in research and then you have to transform that research into innovation, which is putting it in the hands of people and actually being used, and that is also really really hard. I think that's where the hard part is today for VR and AR. I've seen so many prototypes that are not going to be used for the next 10 years. And I think we've all seen them. I'm going to talk about what can be doable today and what we're doing at Lynx as a very, very tiny company. I think we're the smallest headset manufacturer. And what I like to joke about is that for the last 4 years of our burn rate is the equivalent of 4 hours at Meta, if you assume that they spend $1 billion on these technologies per month. So, you really have to put my talk in perspective about the resources we have access to. But nonetheless, we've been working on the Lynx R1, which was a headset I think very well known in the industry. I wish we could have built more of that. I wish I had the resources. It's an amazing product, and no one can take it away from me that we designed it, we built it, and we shipped to customers that demanded a headset like that. And when you take, AR and VR today, they are a set of equations you have to solve, and a set of margins where you can move the parameters you have. But like Doug said, there is no real solution to all these equations in one product today. And when we design Lynx R1 and what we're doing today, which is designing our next set of products, is that we're starting from what do we need, what do we want to see in a product, what can we do with the supply chain, not with research only, but with the supply chain, and what can we ship in a decent amount of time. So, the Lynx R1 is famous for that because we made a Kickstarter, we made a few communication, but most of our customers today are in enterprise. And I think in AR and VR, especially, the question is AR there today in optical see-through? I'm not sure, because people are talking about the Meta Ray-Ban as being, augmented reality, but there is no display in it. So I'm not counting it. I know it's not part of that category yet for me, but for me, AR and AR, and especially MR, where we're focused, is really big and really happening in B2B, in enterprise application. This is a real market. The products sold in that are not necessarily subsidized like in like the mass market products that we see out there. And we have a lot of customers. We have a lot of feedback on Lynx R1 from the biggest companies on the planet. We're training astronauts. We're training surgeons here. We had a lot of field experience about MR, like mixed reality. Is it okay? Can you use it in locomotion? What is your ideal form factor with that? The power consumption, etc. So That's where our expertise is. We take innovation like a lens or display or cameras, we integrate that, and we make it a headset. So we are not components manufacturer, we are component integrators. And that's the exploded view of our first product. And everything you see on that slide was precisely designed by the team, by our hardware team, and every line in the product is a function of something. There is, you have so little margin when you design AR and VR product that nothing is left without any consideration. Because we're in an optics conference, I can talk briefly about the optics. I think this product, Lynx R1, is remembered because of the lens it used. The calibration of that lens was absolutely crazy. The lens was, I don't know if some of you remember that company called Limbac. They were in Spain, and we used their what's called a catadioptric four-fold prism, which basically is a 4-channel lens. So you have one LCD, which is low cost, like $40, $30 at scale. You put that prism in front of it, and there are like 4 areas. And on the display, you render one image that with a shader you explode in 4 with a specific function. And the lens recombines those 4 channels in your eye in the defined eye box, which is always too small, right? And that was our optical block. You have to take into consideration that when we designed that, pancake lenses were not a thing. They were not even prototyped or shown at anywhere. This was like in 2020, 2021. Quest 2 wasn't out there yet. So it was, the world was Fresnel lenses for VR headsets. And when we saw that design, it was the first design that could achieve, a very small form factor. And what strikes you with the Lynx R1 is it's smaller in reality than when you see pictures of it, like here. And you can see that the headset is super thin. It's actually still thinner than the Quest 3. And you don't lose any light efficiency like Pancake. But Limbac was, of course, acquired by Apple in January 2023, which is, for a company like mine, the very difficult thing in AR and VR today is that it's a market that is being consolidated in the sense that the big ones are buying the small ones, like Snapchat, Meta, Apple, all made acquisition of companies either building headsets or building components like waveguide or displays that are part of the supply chain. You might remember Wave Optics. You might remember a lot of them. So it's a very good sign for the industry because it means that it's going to converge to product built by these companies. But it's a really bad sign for competition, especially newcomers. And I think Lynx is the only European company that is going for the future and the near future that is able to compete on standalone headsets. The barrier to entry right now is just too high. We passed that because we entered that space 4 or 5 years ago. It's now way too difficult. And when I started that company, I was younger, and I thought to myself, why is no one building that? Why is no one doing these things? It's not that difficult. But then we shipped the product, and now I understand why we don't have any competition in Europe at all. And why the other headsets manufacturer, when you look at them, the smaller one next to us are billion-dollar companies. Like HTC is still a billion-dollar. It's a small billion, but it's a billion-dollar company. And the big ones are trillion-dollar companies. So the market is too much consolidated to see new integrators come into play. It's going to be really, really hard. And the last one that tried, like Magic Leap, for example, they raised so much money that they left a very, very bad taste to investors. I think they raised, I don't know, close to $4 or $4.5 billion. So, I can tell you from like first-hand experience that when you talk to investors, they usually get back to this wave of AR and VR computing and say, well, these guys raised billions and didn't ship in, they didn't really ship anything convincing. So why would you achieve that, especially in Europe?
Tell us about
But-
more your success stories, Stan, because I know that your headset was used by the famous Jean-Michel Jarre for his shows. And
Yeah,
you know,
that is
it's not
true.
because you said that before you target that, okay, that we target professional environment, but this is a pure performance and a show.
No, the headset has been used. There is a very, very strong demand. Jean-Michel Jarre, for those of you who don't know, is a good friend and electronic French artist that the last thing he did that you might have seen is he closed the Olympic Games ceremony with electronics laser show. And he used our headset to perform at the Versailles Castle in Paris last Christmas. So, in culture, in industry, in medical, in defense, there is a strong need for MR systems. And I'm saying especially MR systems because these are the things that work in terms of the components that those people need. In terms of, optical see-through, to give you, Douglas mentioned waveguides at some point. The image quality, especially the color uniformity you have in waveguide, is not tolerable for people in the industry or in the medical field. When you display something red, it should be red. It shouldn't be another color. So you have to trust the image. And another example of that is at some point the Quest products were having a lot of distortion on the near field pass through. And so in the professional world, it caused a lot of mistrust in the image that these people are seeing. This is because this is not how reality works, and they try to compensate for something that user didn't really cared about. Because, for example, the Apple Vision Pro doesn't compensate for that, and people are just fine with it. And it's the same for the Lynx headsets. Their thing, and another thing that Doug said that really resonated with me with the question of the birdbath optics, with the second order reflection. Yeah, no one cares about that. No one, CalcuTag will probably make you cry, of course. But the consumer, what they care about is just so far from our little world of optics. You would have no idea. You would have no idea. Yeah, I've had people on show floors telling me that they liked Google Glass because it was 100-degree field of view, and they had no idea it was, I don't know, like 10 or something.
Tell us more about the architecture, because on one of your slides you have an architecture. So all of these components, you're getting, you have a partners for developing them. On the previous, when you have a blown out headset, you have a partners for all of these components.
There are things that we developed internally, and there are things that we are taking almost off the shelf, or that we are made done by other people. For example, we can do, in Europe, we have no one to build semiconductors, and certainly Lynx cannot do that. So we use a Qualcomm chip like many other headsets. So we partner with Qualcomm for the main board electronics, or for the cameras, we use OmniVision. Right now, I can share that we are working with ST. They have amazing sensors. This is a free advertisement. They're not paying me anything, but you should definitely take a look at ST if you're designing anything with imaging sensors. There is another demo I can talk about. I tested something. It's a company called Lark Optics.
Stan, I have to interrupt you because we're starting to be slowly out of time, but it's a very interesting conversation to continue. But since you've mentioned of having the partners, I would like to introduce you to actually one of the guys in the room, that is Alphamation, and they are excellent partners for developing and testing actually diffractive optics. Sebastian, if you've seen the set, what is going into the device, how can you help?
Yes, hello, thank you, Olga. So I am sharing my screen now. I hope you can see it correctly. All right. All right, thank you. So indeed, we have heard many interesting talks so far about VR, AR, MR applications, and we hope at Alphamation that some of these applications will end up in mass production. Since we are ready with some solutions to test the micro optics that go into these devices. For example, to test diffractive optical elements, collimators, and meta optical elements, which, for example, for VR headset could be used for hand gesture recognition by projecting a dot pattern or line pattern by using a module made of VCSEL or collimator or DOE, or the version with the meta optical elements, which allows a compact design by combining the collimator and diffractive function into one single meta element. So these can be made and tested on wafers, and we use a conoscope to do this to acquire the angular distribution of the light. And this way we can verify the uniformity and the efficiency of the different devices on each device on the wafer. And for this, we use the Wallet platform, which stands for Wafer Level Optical Tester. And you can see here a small video. I hope it's showing correctly, but it's fully automated with a lot of degrees of freedom, integrating different instruments, one of which is the conoscope, and we can reach testing speed up to 3,600 units per hour with a good reliability, repeatability on the tests, and allowing to have a high throughput in production phases. We developed these solutions maybe 5-8 years ago when the 3D sensing was a hot topic for smartphones. It's still today, but nowadays it's more a controlled solution technology. So if it's for us quite a good and robust solution nowadays, and it can be applied to VR headsets also for 3D sensing. And just to finish, we don't only test on wafer, we also have platform like the one you see here with the pick and place robot, able to test assembled devices and modules, including electrical contacting, including displays with optics and so on. So with a more complex testing.
Thank you, Sebastian.
If you have any question, please go on.
I actually would have a question to both Stan and Doug, because now there are quite a few specifically micro optics elements that are going into for the sensors and for sensor solutions. But one of the applications, one of the solutions that is also, let's say, on the horizon is meta lenses. Or let's say all these flat lenses, let's say flat optics for developing the sensors. What would be your perspective, as the guys that gonna incorporate it potentially into the sensors, into your products? What's your view on this, Doug?
Yeah, so on the sensor side, that's interesting to consider. I think, in the published work from my team, right, we've tried I mentioned this holocake system, right? And so that's where you're replacing refractive pancake optics with literally a hologram or some sort of polarization sensitive hologram. And so there, I think the challenge with diffractive optics is, of course, the clear aperture. You're making something enormous. The sensor sounds like a gift, like, oh, I'll just make this tiny little diffractive. So I haven't published a lot of work there where we've moved the sensors towards a diffractive regime, but I'd say for the viewing optics, certainly mass producing those, right? Like I really enjoyed Stan's talk, and it's the challenge, right? As a researcher, I can make 1 to 10 of something, and then there's this huge band gap to making a consumer product, right? And I wish there were things in the middle. And so I think for these viewing optics becoming diffractive, I do worry, like I could make one, but could we mass produce them? Can we make laser sources, right? Now that it's diffractive, right? At least on a display, I can control the illumination. For imaging, not so much. So that's really where my head is at within the work I've done, is seeing, if we can start pushing towards diffractive viewing optics, and obviously that opens the door to holography. So can't comment as much about the sensors, not as knowledgeable there or experienced.
Stan, what's your view? Do you think diffractive optics and meta lenses will specifically find its way into these sets?
I certainly think so. Especially, I think it was Neil that demonstrated before they got acquired or merged with another company, they demonstrated a very tiny camera. And if you need to see things in a specific wavelength with a specific aperture, and I think eye tracking would be the first application where this is efficient, then definitely, yeah. For imaging sensors, diffractive optics could be a super interesting option from a mechanical point of view. But again, the question remains on, the BOM cost of all that. So yeah, a few more years, I guess.
And you also, because you mentioned, that, yeah, from transitioning from the research project, or let's say from R&D to the product development, you start to think, okay, we need to go into the masses. And there was actually one comment that in the chat box from OptoFidelity, who would said, we can do the mass testing and drop your costs for the testing your manufactured headsets. And we have Pekka in the room. So Pekka, please tell us what's your solution and what's your way to further decrease the costs for manufacturing and testing the VR headsets.
Well, thank you, Olga. Hopefully you can hear me and see the slide.
Yes.
So today, I've been seeing, first of all, excellent presentations here, and lots of the discussion has been around the actual displays. And as you mentioned, that we are doing a lot of display-related testing. But today I'm talking about the actual head tracking. So this kind of puts the end user performance in the center, and how to combine all the sensory data, and then create the rendering, which is then displayed in whether it's optical see-through glasses, AR glasses, or these more traditional MR, VR type of a headset. So about OptoFidelity, we're a Finnish company, as mentioned, focusing on the AR, VR display metrology solutions, and we've been on the field for a long time, over a decade now. So we have seen all the ups and downs in the field, and so now when it comes to the head tracking performance, there are 4 key factors recognized that affect the end user experience. It is typically the latency. So latency means naturally the delay between your movement and the virtual content which you are seeing. Then there's drifting. This means that when the virtual world shifts and like over time. So there has been lots of commercial devices in the market, while once you have been using them for a while, that the content is actually moving. So there was this one not to be mentioned headsets, 3DOF headset some years ago, when you were watching a virtual movie, if the battery lasted long, after 20 minutes you have to actually turn right a bit, so they kind of follow the screen. So that was luckily fixed by a software update, but there was clearly a challenge there. The third item is the position inaccuracy. So this is mainly just like how accurately it's tracking your movement regardless of the time. For example, in many applications, you have to anchor some object to the real world. I don't know, doing brain surgery or defusing a bomb. So you want to actually make sure that it's showing the right veins to cut, or the right wires to cut. And then last but not least is the jitter. Jitter is now it means the random motion, or let's say the shakiness of the image, even that it's supposed to be still. And there's many reasons and many factors which are causing all of these items. And now, ideally, in the perfect world or in the perfect headset, there would be zero difference between the movement of the real world and the virtual content. But of course, the real reality is that there's always some level of delta between these two, and typically this then defines how good the user experience is. And so, okay, this is you can see here is one of our flagship products. It's called OptoFidelity Buddy. it's designed to measure this delta by using a robot to move the headset, and then using our proprietary technology to measure the virtual content directly from the display. Well, this allows you to accurately characterize the performance of any types of a headset, be it a VR headset or some pilot headset, or just typical these type of mentioned, for example, bird bath or other type of optical see-through glasses, which have this slam built in there. Of course, a little bit bad for the body, since the bigger trend now seems to be that these smart glasses without any head tracking seems to be now getting more popular. But luckily, there is still a really relevant market where this type of head tracking is needed. But anyway, we have a strict timeline here. So for more information and such as white papers or benchmarking results, by the way, we have been comparing a lot of commercial devices, and we have some material available in our website. Unfortunately, we don't have links yet, so we are happy to measure for free, only for you, Stan, the links tracking performance. We would be really interested to see how that performs. So please visit our website or reach out to me directly, or Murat. I think he's also in the chat.
Thank you so much, Pekka. I think that's an actual invitation for collaboration. Stan, you have to address it. That's for sure. And we actually have a question and comment from Josh from EdOptics. Josh, go ahead.
Hey, I just have a quick question. So I know Opto Fidelity can answer this, but so as I said earlier, my background is in AR, right? And VR, I worked there for 3 years, and now I'm getting back into it. But in the AR industry, specifically for metrology testing on displays, right? And I'm assuming it's similar in VR. Every single OEM and ODM and every single component maker, device maker, they all have their own standards, quote unquote, for testing. And frankly, on the component side, on the ODM side, they create their standards based off their own products rather than an industry standard. And so you can't believe anything that comes out of it. And then every OEM has their own standard. So my question is, will there ever be a unified standard for VR and AR for metrology testing? I know Opto, Fidelity's got their production IQ and the buddy and things like that. But how soon until we actually have a standard across the world for AR and VR for testing?
Excellent question. I would say it might take over a decade. It depends. If you're talking about only one standard, it will take years until we have lots of products especially in the consumer market. So now there's, of course, as you are aware, the different associations in different countries or whatnot, trying to establish these type of standards. Many of them are very similar, but until we see these big giants coming with their products to the market and kind of setting up the standard, like, again, it doesn't need to be perfect, but like. So I think it could follow the similar way as the mobile phones did. So my guess is, again speculation, but I would say that it will take still probably a decade. There will be standards for AR, there will be standards for VR, and depending on the use case. So now if you're doing the brain surgery or just playing games, I guess it's
yeah. Well,
yeah, I hope.
I can reference Opto Fidelity, right? So previous job, we worked with you guys a lot, and your standards were always fantastic because they were real. And so I think that whoever ends up, if one of the big guys, Douglas, if one of the big guys end up actually creating a standard, as you said, as long as it's real, it'd be fantastic.
I think we have actually one of the big guys in the room, at least when it comes to the production, and it's Jabil. And I've already seen Sven like nodding his head in agreement with everything what Pekka said. Sven, go ahead. What's your comment on this? Testing, you can produce many of them at your facilities. I mean, you're world famous contract manufacturers. When it comes to the testing, how do we do with the standards?
The most important is that everything needs to be tested. Everything needs to be qualified. You can in this world of consumer optics, you can only survive when you have, a yield which is in the high values, close to 100%, minimum 90%. Below that, you're simply just burning money. And the only thing how to do that is simply qualifying, testing, and that in the right manner. That's simply
What it takes.
a small statement on that.
Then tell us maybe more about your solutions, because as a massive contract manufacturer and for, I guess, also for testing, what is your contribution to this growing VR and potentially MR field?
Simple thing. We are maybe the only company which does not have any product. We are just offering services. And we are offering services of producing your parts. And to make them producible, we are offering also our design services and helping you to simply bring everything from any stage where it is either in the concept stage, at the ideation stage, or it is already nearly ready to be industrialized, or anywhere in between. We are helping you to ramp it, to bring it to the customers. And that's simply what we are doing. We are there to help you at any stage to bring the product to life. And that's what we are doing. In special thing, what we are in the, as Jabil Optics special in the Jabil universe, is that we are an engineering site. We are not doing the mass production, but we are helping as incubation site. We are helping you to bring everything to the mass manufacturing sites. And typically our customers are startups. They are big tech companies, and in these companies, small teams, which wants to bring a new product, a new device, a new version of whatever into the market. And we are helping them to build the prototypes. We are helping them to bring the stuff into the stability, what it needs to have them, what it simply needs to have to be produced. And we are not just building that stuff, we are also helping you to maintain the supply chain, secure also the quality of the parts, so taking care of OQC and IQC. Simply, we are helping you to do the things what you are doing slightly better, slightly smarter. That's simply what we are doing.
Sven, from your perspective, of being able to mass manufacture things, what do you believe would be the promising technologies to actually increase the volume for manufacturing for the VR sets, and what is needed? Because there are quite a few critical components, that.
Yeah, I think on. Sorry.
Sven?
So from my point of view, there's one simple thing missing, and that's the Pokemon Go.
Mm-hmm.
When the Pokemon Go thing is there, from my point of view, the devices, the solutions are already at the glimpse of being there to be mass manufactured.
Okay.
But the application is simply missing to make it really attractive for the mass market.
Okay.
We are ready. We are ready to help you to ramp everything. The application needs to be there.
Thank you for your point of view. And then, looking a little bit into the future, because maybe not the Pokemon Go, I would probably prefer Prince of Persia, but I see your point where we go. But when we look into the future and, seeing where the technologies go, I would like to introduce one of our last speakers. is a Nexus Photonics, which are actually developing the platform, the innovative platform for the next generation, or let's say for the future of the VR and also IR. So, Tin, please tell us a little bit of what you do and how exactly you plan to transform the VR world.
Thank you, Olga. So yeah, my name is Tim Komjanovic. I'm the CEO of Nexus, and I'm extremely excited to be here. We've been in stealth and are, partly still in stealth, but essentially towards the audience that's here today, what Nexus is doing, we are essentially redefining the illuminator, the optical source subsystem that can enhance depth perception and, tracking to give you greater robustness and better precision. We do that by developing a fully integrated photonic platform that essentially enables a user or a customer that's going to assemble the system to basically pick what they want to have inside a single chip that's manufactured, tested, and simulated at wafer scale. And so coming to the options that you can kind of think of, you could choose the wavelength of operation. Let's say maybe 940 could be the most interesting for the audience here, but you can go outside those ranges. You can choose the type of source you want to have integrated. It can be broadband. Do you worry about speckle? It can be something that's single frequency, or it can actually be tunable if that helps your functionality. And then you can use very advanced beam shaping using advanced lithography and multi-layer structures. So you can have a very collimated beam with no external lenses. You can have a very highly divergent beam, exceeding 120 degrees. You can generate fringes, you can generate dot clouds, or you can actually combine all these things. And then beyond that, which maybe you could have done in the past with assembly, you can make all that steerable, including continuously steerable. You can have on-chip photodetectors that can help you monitor power, but can also help you, receive signals and do processing. And then, that's just one piece that you can then multiply across, and you can have multiple switches sources or multiple outputs. And so, you really can tailor it how you want to do it. And then coming to the scaling that was talked before, our photonic integration is full wafer scale. That means that whole functionality is integrated as the wafer is completed, including the sources. And you can see here an early prototype that's automatically tested across a wafer. It has more than a laser, additional functionality to control the beam, etc. And then you can singulate it on wafer scale, and then you can also package it. And these are early samples that are tested at experimental stage. But the key here is that these guys are fully encapsulated, and there are no exposed 3-5 facet, means that you don't need any hermetic packaging. So the packaging can be extremely low cost. And so looking from a very high view, it's going to give you the smallest illuminator possible, fully integrated single chip. It's going to be very capable. You can steer, add sources, etc. Extremely scalable. This is all about volume. This is how you do this at 10 million, 100 million units. And it's low cost because it is a fully wafer scale process we're testing. So, we've been in stealth. You have my contact details, lower right corner. You can go to our website. If this is of interest to you, we would really like to talk to you. So thank you, Optica. Thank you, Olga. And thank you all for your attention.
And thank you, Tin, for sharing. So I'm curious, when I'm looking such a novel solution, a little bit futuristic, I'm always thinking, okay, what are the guys that are already in the field? We have Doug, we have Mark from VividQ, we have Josh. Like, gentlemen, what do you think about integrating photonic integrated circuits into the future VR headsets, VR, AR, all of these solutions? Doug, I'll call you out first.
Yeah, I mean, I think like the earlier discussion of, meta optics and diffractives, I mean, obviously, as the ingredients change, that's at least the type of research I like to do. It's at the system level, right? I'm not making new types of photonics. So, it's exciting to watch. Certainly I've been watching, the integrated photonics and sort of wondering when that can come to bear, right? If it can only make a few sources, fine, we'll make some like illuminators. When can it make the display itself? Well, that's pretty far off in academia. But yeah, this is, we all stand on the shoulders of giants, and often I feel I'm just grabbing the Lego bricks that companies are giving like this. So I'm excited. Any progress means we can do something new at the system level.
Tin, what do you think the horizon? When, in what time frame it can be really available for in a large volume?
So, I kind of think it depends on, volumes. If someone needs 10,000, we can do it today. if they're going to need 10 million, then they should talk with us and we should do a long roadmap of how do we make that happen, But we really kind of hope that there is a 10 million unit application, yearly volume. Then integrated photonics really shines. Then, you can get it for $1 pick or something like that. And, then the consumer is really benefiting from all of that. So hopefully soon, but let's see.
Josh, would you have something to add? You're a very long time in this field.
Yeah, I think, anytime you can integrate anything into the wafer, I mean, it's the same thing as the ad optics, right? Integrating, eye tracking and depth perception, directly into the prescription lens, it's the same thing, right? So, if you can integrate anything to make the overall product smaller, right, and more efficient and more better with the battery and et cetera, et cetera. Anytime you can do that, it's fantastic. It's taking it from that 5 or 10,000 a year or a month up to hundreds of thousands a month. That's the key, right? And I've competed with companies that for waveguides that they will make 2,000 displays in order to get one pair that they can demo, right? And it's got to get past that stage, right? And then there's companies like my previous company in ad optics who can, the yields are significantly higher, but even then, they have to have mass production. And so I'm really excited to where Nexus is going. I've been watching them for a while. I really, again, the more you can integrate into a component to allow the device makers to save on shape and have a more meaningful experience for the end user, that's what it's all about.
And since you've mentioned the end user, I would like to give the floor to the last of the speakers of today, who is actually the true end user of everything that we discussed today. It's Johan Kruse from Volvo Trucks. Johan, let us know, that with all the headsets and with all the technology, tell us how you actually use it and what's your perspective on the VR.
Yeah, thank you for this. I'm happy to have the opportunity to be the end user representative. So I will share some slides here. So please let me know when you can see my screen.
Crystal clear. Yes.
Great. Yeah, my name is Johan Kruse. I work for Volvo Trucks. I'm working in the competence development field for dealers. And since the last 2-3 years, I've been working a lot with virtual reality and try to scale this up because we have been using this for a very long time, but in small scale. So I will talk a bit about that and when we are using it and so on and so on. And and this guy, as you see here, he's from Taiwan. He's 50 plus and he's really into VR. And among other of our target groups, because the main target group that we have are technicians, and they are both young ones and older ones. And we have realized that age is not the hurdle for VR anyway. So that's really good. And we are using virtual reality for 5 different purposes. We use it for safety purpose, to overcome distance, to get access to components and products, and since VR also is very effective for learning. Since we are using, when it comes to technical training, for example, we use a lot of hands-on training because it's very good for learning, and VR support that in a good way. And right now, we in Volvo Trucks, we have 5 sales areas. It's a huge company. I mean, in Volvo Group, it's more than 100,000 employees. And our target group within Volvo Trucks is around 20,000 technicians. On top of that, it's a lot of sales personnel, parts personnel, managers, and so on and so on. So we have a huge target group. And right now, we are live with VR trainings in 46 markets. I think it's even more right now. I think it's around 10 markets that are using VR on a regular basis, weekly, monthly basis. And we have like 8 trainings, 3 products, 3 components, and 2 Vista stations. It's increasing all the time. And right now, several thousand of our technicians and hundreds of sales personnel and around even 2,000 customers have participated in one or several of our VR sessions so far. So it's going big, this, and it sets a lot of ultimate pressure on us, of course, as a delivering organization, and we're learning all the time on this. And we're working in different levels. We're working on the platform, if you go from the bottom here, to create a good lobby experience, to be able to easy access sessions. We have an integration with our learning management system, and we're also working with support, since it's very important that end users get good support really quick. We're creating a component garage, which means we can bring in components, on demand into training sessions, such as gearboxes, engines, and electrical systems and brake systems and so on, to share and show, because we see that VR is very good for this, because we can show what everything is looking on the inside, and we can show different flows and so on, which is really complicated to explain theoretically. So that's very good. We have been using recently also VR in our launches of new trucks, where we just released a very big launch within Volvo Trucks, the biggest ever, a Volvo Aerocab. And in that launch, we used also a VR app for these markets that haven't got any real truck. They used a virtual truck instead, and got super good feedback on that. So we will continue on that going forward. So yeah, we're doing a lot of things here, and we will continue to do that, of course. As you see here, 2017, we have 4 headsets in our markets, in our global organization. That was not a lot. You realize that. But then I think the game changer come with the COVID, and at the same time, we had a huge product launch where we release our heavy-duty electrical truck. And for that, we needed to train our end users, our technicians or our technical trainers, but we couldn't travel. So the only way for us to conduct hands-on virtual training was to use VR. And that kind of, I think that took us from the starting block, because we had no other options. So I think that was the main driver for us going forward. And after that, it has increased more and more and more, the demand for VR training from our markets, and also all the way out to the dealers. From 2020 to 2023, we had around 300 headsets in the organization. And this year, the ambition is to at least get approximately 1,000 headsets out in our organization, and even more, because we have 2,000 dealer sites globally. And the vision for us is that every one of these dealer sites should have at least 1 headset available. So, and yeah, that was what I would like to share super quick. But anyway, this is on some pictures from one of our events using VR. So.
Johan, but as the end user, you have now an opportunity, you have all the tech guys in the room, and you have an opportunity to share your wish list. So
Yes.
what would be your wish list for the improvements or for the next advances for the VR headsets?
Yeah.
What would you like to see coming to reality?
Yeah, one of the feedback we have got from our users, of course, is in some cases seasickness, latency, performance, frame rate, lag, and so on. If the performance would be even better, I think, then the seasickness risk will decrease a lot. I think it's getting better and better. We see that when it comes to the MetaQuest 3 instead of MetaQuest 2, it feels better from the end user perspective. We've got that feedback anyway. I think as well the hand controls. It's when we train our network, I think the biggest issue to train is with the hand controls. Because it's a bit tricky to understand how they work and so on. But after some time, of course, everyone understands it. But we put a lot of effort into that as well. And we are also exploring the hand tracking functionality. I think as well, if that could be even more, developed. We think it's super good even now, but even better than it would be even easier for us to train our network. Battery capacity, to make the battery last longer. I think that also would be nice. And also we have seen how with the MetaQuest 3 headset, hand controls, when that the batteries, the battery time is quite low. I don't know if we are doing something wrong there or something, but it feels like it drags battery even if we don't use them and so on. So and simplicity. I mean, the more simple we can make it, the better it is. Because I mean, our talk group was not maybe super tech geeks in that sense, but the more simpler we can do it, the better it is. And I mean, it's yeah, that's what I can give to you. And we are super satisfied with the product, of course, with what we have. I mean, we are doing great stuff here, and I'm so thankful that we have this opportunity. So yeah. We are
Thank you,
just
Jochen.
started this journey, so we will do a lot more in this going forward.
Thank you, Jochen. I think Doug, Stan, you were now challenged by the end user, and you have really a little bit of the room for the improvement, clearly. Thank you so much, everyone, for these 100 minutes. It was a pleasure to have all of you. Thank you for joining. Thank you for preparing. It was interesting, insightful, and very helpful for all of you. Bye-bye, and then wishing you still a good evening, good afternoon, and thank you so much.